First off, I think I'd better apologize that I'm going to talk more about gravity than electric universe, but I think you can see a few connections as we go along. I didn't know how to organize this. Clearly, I'm going to present it in a way that it wasn't derived, and what I'm trying to do here is simply to show some agreement with facts and ask questions. What's theory say? What does the evidence say? And in what's next, I'm going to talk a little bit about the electric universe. So if I can get through it. I've got too many slides, I'll admit. Okay, we'll go ahead. First of all, I think there's some guiding principles we need to follow. A reliable experiment trumps any theoretical claim, first of all, and rational explanation trumps any magical mechanism. There's quite a bit of magic in special relativity, and that's partly why I say that one. I like this verse from Proverbs that Solomon, he was probably the leading scientist of his day, so I think it's insightful. Here's a few nice quotes that I just couldn't help from putting in. The tendency of a group of human beings to quickly come to believe something that its individual members will later see as obviously false is truly amazing. It is controversy that keeps science alive and keeps it moving. And science is the organized skepticism and the reliability of expert opinion. I tend to agree strongly with those statements. Just a little background. I've written a bunch of papers. I figured I'd put them here. If you have questions, you can probably find them. These are, the last one there hasn't been accepted yet, but I'm fairly confident it will be in the near future now. It's been in process of 2 years fighting with some of the reviewers. Okay, now into some of the questions and answers. I've tended to put in red things that I disagree with, and I haven't followed that carefully, and green things that are true. And here's some things about GPS that I think they have pictured properly. And one of those is, what effects does gravitational potential have on an atomic clock? Clocks higher in the gravity field run faster, and also in motion, what does kinetic energy, not just velocity, but kinetic energy, speed of movement, have on atomic clock rates, and it slows them down. And there's clear evidence for this. GPS in an elliptic orbit, it's not highly elliptic, but elliptic enough. When it's near perigee, it's going faster and it's lower in the gravity field. The two effects are identically equal and add together. And in fact, the equations in different uses, sometimes we'll compute the velocity and use that and double it, and sometimes they'll compute the potential and double that. Similarly, on the surface of the Earth, because we're spinning, a clock at the equator, for example, is farther away from the center of the Earth. It's got a lower gravitational potential, and that higher gravitational potential, higher up, causes it to run faster, but it's spinning, which causes it to run slower, and they exactly cancel each other, so that if you had a mean sea level all the way around the Earth, all the clocks would run at the same rate. Kind of interesting. The next is the theory equivalence principle. Gravity acts on electromagnetic radiation, and here's what the recognized authorities say. And here is where we run into some real problems. The claims, the frequency energy of electromagnetic radiation which rises in a gravitational field has a redshift, i.e. it decreases. When falling, it has a blue shift, or increases. And I show that 4 people here, Einstein, Feynman, Clifford Will, and Neil Ashby. Will and Ashby are current theorists that are well recognized, and they all claim that this is the case. Well, they use an energy argument from Feynman and Einstein. One of them talks about frequency, one about energy, but it's the same thing. The argument is made by the conservation of energy. It takes energy to move an atom up in a gravity field, and then you let it emit some radiation. You lower the atom back down and let it absorb electromagnetic radiation. Well, the energy of the atom is different, they claim, and therefore you have to have the energy of the radiation that's gone between them has to change, or you wouldn't get back your original energy. Well, what's the problem with that? The critical assumption in the Einstein and Feynman energy argument is that the same amount of energy is required to emit radiation from an atom independent of gravitational potential. Well, this is not obviously true, And I will show that, in fact, it is obviously not true. First of all, the transit system and GPS both show that, in fact, the frequency as it falls from satellite to ground does not change. In fact, I find it highly interesting that Clifford Will admits on page 50 of his Was Einstein Right that clocks are affected when you move them up and down in the gravity field, but he says we can't really know if it's a clock rate because it's not measured in real time. Yeah, just some real beautiful logic here. So I claim that it is the frequency emitted which changes and not the frequency in transit. For example, the famous experiment at Stanford where they let radiation fall in a tower, it was the fact that the clocks that they measure the frequency with is different, not the fact that the radiation changed. There's direct proof available from GPS to show that this frequency does not change in transit. I think this is the best case that I can make. GPS sends a modulated signal from satellite to ground that's binary encoded, and it encoded in it is the time at which the signal left the satellite, and the time at which it reaches the ground then can be measured. The difference in time sent and the time received is multiplied by the speed of light to get the distance. If the frequency or energy increased in transit during the time, the phase reversals would be wrong and the measured distance would be short. Well, maybe it is short, but the integrated carrier frequency would get shorter and shorter because it's all continuously decreasing. And in fact, my old Hatch filter where I smoothed the code measurements with the carrier to get higher accuracy would diverge. It doesn't diverge, therefore the frequency cannot be changing as it falls. And here's that outstanding logic again, I say, from world-famous relativists. Clifford Will, I already mentioned, he says you don't know whether it happens in real time or not. Neil Ashby, I call this double or nothing quote. Second, the strong equivalence principle implies that light traveling downward in the gravitational field is shifted to a higher frequency, i.e. it is blue shifted and gains energy. As a consequence, atomic clocks at a higher elevation of the gravitational field run faster. I say, what? What kind of logic do these people are trained in? I think, quoting from Peter, just a phrase in the New Testament, they are willingly ignorant. I happen to know, for example, Clifford Will, a graduate student of his, called me once after he read one of my letters and said, I talked to Will about this, and he says you're wrong, and when he gets back from vacation, he'll let you know. Well, that was 2 years ago. I presume he's back from vacation by now. And Ashby recently submitted an article to that same magazine that I had my first paper in on that list, and it essentially addressed the same issue that I addressed 7 years earlier. Well, he came up with a weird explanation for the same thing that I explained, I think, logically. I criticized it back to the editor. Turns out the editor is a friend of mine, or I would never have got the original paper published. But so I sent the criticism back, and that's been 4 or 5 months ago, and the paper still hasn't appeared. So I'm beginning to think that they are, as I said, willingly ignorant. They don't want to look at the facts. Okay, there are a lot of related questions, though, if you follow this logic to its natural conclusions. Incidentally, this is Sheldon Harris. Again, I saw one earlier of this same picture, I think. He hasn't made any progress with his theories, so he's beginning to work on his resemblance to Einstein. Okay. Where does gravitational potential energy come from? How does the gravitational force arise? Do inertial and structural mass diverge? How is the total energy split between structural energy and kinetic energy? Is the matter wave frequency or energy defined by twice the classical kinetic energy, and can black holes exist? So let's look at some of the implications of that fact that the frequency doesn't change as it falls. It has some huge implications. First of all, we can reverse Einstein and Feynman to say, obviously, if the frequency hasn't changed going up and down, then the energy hasn't changed of the particle itself. Well, that means that this energy of falling must have come from the structure itself. In other words, the rest mass energy, I'll show later, I'd prefer to call it structural. The structural mass energy is what has changed and provided us our gravitational energy. Since radiant energy doesn't change, the kinetic energy of fall must come from the decrease of the rest mass energy. And that's a big implication. There's some gravitational force implications. If gravitational energy comes from the rest mass, the spatial gradient derivative of the energy should give us the gravitational force. And it does very closely. If I use a gravitational scale factor for lengths and energy and et cetera, which we'll go into a little more, Einstein has the square root one there. I have instead an isotropic one, it's called in some of the literature, but it's the one I get when I say that matter is made up of resonant spinning ether blobs, if you will, and low. And because it takes reaction time of the ether at c, that's where we get mc squared. In any case, if I use the exponential form, you'll see it differs only out there in the second order. But when I take that potential energy and take the gradient of it, a big difference. In the isotropic form, I get the scale factor in the numerator here, right there. And if I use Einstein's, it goes in the denominator. In other words, the force would increase as I fall, even though I know I'm losing energy, structural energy, which I think is the gravitational potential energy. So the isotropic form has to be the correct form for me to gain energy from the particle itself. Well, this has other interesting implications. In fact, if you pursue it to its logical, the g itself has a scale factor. I almost neutralize that by putting c fourth in the denominator and saying the force is generated by the energy of the rest mass energy or structural energy of the source and acting on the structural energy of the particle, which now is decreasing in energy as it falls. And in fact, this explains Halt-Narp's low energy, I think, because as you add more and more mass, it has less and less effect. Incidentally, that rules out a black hole, among other things, but it also explains quite a bit of Halt-Narp's observations, I believe. Since they measure how much mass there is in a star by the orbiting stars around it or whatever, this decreased force, because of this decreased S, also says that they're measuring the mass too low, which explains why some of the blue stars have a red shift that Halt-Narp explained, and fits together with it being a gravitational shift and works out very nicely. Gravitational scaling and no black holes. Shapiro experiment did radar time delay from Mars as it passes behind the sun and showed that, in fact, the speed of light slows as the square of the gravitational scale factor. Local time intervals get longer by the inverse of S, clock frequency slowing, which implies that lengths shorten by S, and that means the structural energy decreases by S. The mass itself increases as the cube, but the energy decreases because of the speed of light changing. And black holes, the gravitational force is self-limiting. The structure and gravitational energy decrease proportional to S. Gravitational force does not act on electromagnetic radiation, which means that any emissions from if a black hole were there, if it were straight up, it would have no effect. What you're seeing is just simply the lower frequency at which it was emitted. Now, it is true that there's some refraction effects, so if it came out at an angle, it would dim that result. But the major effect is there obviously could not be a black hole. Okay, weak equivalence principle. Gravitational and inertial mass are equal is the claim, and the energy implications of that. The velocity scale factor I give over here, and there's the total energy, the potential energy plus the kinetic. The components of the total energy, I say the structural and the kinetic, are given here, and you'll notice that I've doubled the kinetic energy. And that's because I claim that there's a hidden component, which is evidenced by the fact that a moving particle emits lower radiation. So it has converted part of its structural mass, when it moves, into kinetic mass. And that works out for a number of reasons, and it looks like it's great. The identification of the structural, gravitational, and inertial mass then becomes like this. Inertial mass times the speed of light times S gives the total energy, and then the gravitational energy and the kinetic energy. Okay, problem is the decreased potential energy causes the frequency radiated to decrease and therefore decreased structural energy. Increased kinetic energy also causes it to decrease, and the solution is the same. The structural and inertial mass diverge with velocity. And there's actually been some evidence of that in some other papers that I don't cite here. The theory says the rest mass is invariant with frame and energy conservation. The invariance of the rest mass it's really interesting here. In special relativity, they claim that the rest mass doesn't change. Well, if we work through the equations and we expect energy to be conserved, what we'd expect would be that the energy of the moving planet or whatever would be decreased by kinetic energy. And sure enough, when you plug in that into this equation, you get that the structural mass has apparently decreased by its motion factor, and that in fact resets them so that if I'm going to measure them on the Earth, they'll look like they're the same. We'll go into a little more of that. And note that it's numerical invariance and not physical invariance for both speed of light and inertial mass and a number of other things. Confirmation of structural mass decrease in inertial mass increase with velocity, which is contrary to theory. The frequency of emission absorption increases with potential energy, but decreases with kinetic. Pound-Rebke experiment I mentioned earlier. The frequency energy of matter waves is twice the classical kinetic energy, and I've never seen anybody try to explain why. Direct tests of inertial and gravitational mass divergence with fall have always been performed at the same velocity, so they aren't even really looking for it. In a given frame, the structural gravitational mass and the inertial mass are equal when stationary, because the kinetic energy is reset to zero in your moving frame. In a given frame, the structural gravitational mass and inertial mass by the same amount as the gravitational potential energy is changed if you're not moving up and down in that potential. Okay, on to the next. GPS and the strong equivalence principle. Theory, here's what the experts say. The effects of acceleration and gravity are completely equivalent. Einstein said it, Feynman said it, Ashby says it in chapter 14 of the Global Positioning Bible, if you will. And let's just go on. What experiment says, gravitational potential causes clock rate changes, but acceleration causes Doppler frequency changes. Well, there's a significant difference there. I can integrate my clock frequency changes and get time. I can't integrate Doppler frequency and get time. By the previous argument from GPS, the frequency does not change when falling, and in the radiated frequency clock reach, which changes the function of the gravitational potential. In GPS, the Doppler frequency can be distinguished from the clock rate by sending the clock reading via the same electromagnetic signal, i.e. modulated on the signal. And tracking millisecond pulsars can distinguish between clock rate and Doppler rate, and clearly shows that they aren't equal. Clock rate integrates into clock time, but Doppler does not. The effects are not equivalent. I do admit there is one minute effect that cancels, and that is with the Earth falling towards the sun as it orbits, and the GPS also falling, it turns out over that 70 milliseconds, there's just enough tiny acceleration of the Earth that it essentially cancels out that clock effect instantaneously. But as we shall see, the integration of it still has good effects. On to theory again. Infinitesimal Lorentz boosts or transformations. The theory claims that they are valid means of adjusting SRT to accelerated frames, and I give a bunch of references for that. Experiment instead agrees with Goy's hypothesis. He's a prof in Italy, and he says that you can't do Lorentz transformations instantaneously all the way around that, but you can set your clock rate instantaneously to whatever the velocity is at that point. And that's proven by the fact in a muon storage ring, the acceleration has no effect, but the velocity does directly affect it. Here I want to do a couple illustrative experiments to illustrate a little bit of this. If you use GPS and free-running clocks to measure the time and the speed of light in orbit around the Earth, and I'm going to measure the speed of light across this bar or even perhaps across this bar, if I gravity gradient stabilize it, for example, so that this always points towards the Earth, then these two clocks on the two edges run at exactly the same rate because they're traveling at exactly the same rate and exactly the same potential. Meanwhile, these two are traveling at slightly different speeds, and that speed is just exactly enough to cancel the two the difference in the potential. And so all these clocks will run at the same rate if I'm not rotating this. If I continue, the horizontal leg is just like GRACE, and the GRACE satellites clearly show they use GPS for time, and they clearly show that yes, the clocks run at the same rate. They agree with the GPS time, and GRACE is just two satellites in the same orbit separated by a couple hundred kilometers. But there's some interesting things that we can also learn here. For light traveling between those two satellites, it turns out it will be measured as c minus v, the velocity of the satellites, because of the transit time, how far the satellites have moved in that transit time. We can reduce that to a distance traveled. We can compute a change in clock that would compensate for it. And it turns out that it's exactly that Vx over c squared, negative. And for carrying a clock, if you look at the gamma factor and look at the center part term, which is caused by the orbit, you get that same correction. The first term, this can be made arbitrarily small by moving slowly, and this one is common to anything on the Earth. So you can get exactly the same effect by carrying a clock from one to the other. Slow clock transport introduces a clock bias, and Einstein two-way synchronization introduces that same clock bias. So they will measure the speed of light as c if, in fact, you try to synchronize them. But if you don't synchronize them and it's not rotating, you won't. Well, next then, what if we rotate it? Or what if we stop the rotation? We were rotating the last one, pointing towards the Earth. This one we not. And one way of doing that would be to spin this thing around its vertical axis, and now it won't rotate as it goes around the Earth. The spin we could use to see that it would create the clock bias between the two that make it looks like the speed of light is c between the two, and the speed of light on these two clocks run at different rates now because of their gravitational potential. But lo and behold, if you integrate those two rates, as this goes around the Earth, this one will wind up being behind it once you've gone a quarter of the way around, and it creates just exactly the right amount of clock bias to measure the speed of light as c again. Well, this is exactly what happens on the Earth. The spin of the Earth keeps the Earth oriented the same way in space, and the spin and the gravitational potential of the sun wind up causing it to make it look like the speed of light is c on the Earth, even though it's not. Okay, I think that's good enough. Next, theoretical claims for a Lorentz transformation, or boosts. If you make two non-collinear Lorentz transformations, they claim it'll create a torque. Nobody knows where the torque comes from, but Thomas gave an original derivation for that on the electron. Lorentz boosts of the Earth cause the cancellation of the sun's gravitational field, according to Ashby. Mueller attempts to explain the torque, and he actually gives a physical explanation, which I think makes sense. The trouble is, if he were right, and if the Thomas precession explanation were right, you'd get twice as much. I do believe that the divergence of structural mass and inertial mass can cause the precession effect. The experiment, gravitational potential of the sun does not affect the clocks. This does affect the clocks, whereas they claimed that it didn't. The frequency effects integrate into the clock biases, and that's exactly by the process I just explained on that spinning thing. The Earth is spinning. As a result, you get some clock biases that wind up making the speed of light look like it is the same in all directions. And when the orbit direction changes, the gravitational potential of the sun is just enough to keep that bias the same amount. So Ashby's claims are wrong. The fall of the Earth does not cancel out any effect on the clocks caused by the gravitational field of the sun. There's another fundamental question we can get back to. What about length contraction? Is it real? If so, what's the mechanism? I claim that the conservation of momentum requires length contraction of an orbit in a moving frame. How do I get this? Well, when you're moving, the inertial mass increases, as the experiments have shown. It turns out that if I'm in orbit around the Earth, for example, up here, when my orbital speed adds to the Earth's speed, I'm going enough faster that my mass is a little higher. Conservation of momentum says I have to move a little bit slower. Therefore, I'm going to wind up closer to the Earth in front. Down here, just the opposite effect. It cancels some of it. I get lower mass, therefore my speed has increase, and I get a little closer to the Earth on the tail end. I believe that exact same thing happens in the atoms and so forth. So that we get length contraction caused by conservation of momentum. Well, there's another amazing fact about it, and that is it's exactly the same clock bias that will counteract that slow, tiny velocity change and make it look like we have uniform momentum in an orbit around the Earth, even when the momentum is not uniform. And the clock times, I could use this as a clock and see that there's clock slowing and so on and so forth. Okay, theory says the speed of light is physically invariant. Wikipedia questions it, and I say the real question is the speed of light physically invariant or simply numerically invariant in a local inertial or local gravitational frame. Shapiro radar time delay shows that the speed of light varies in the gravitational potential, and I say lengths shorten, frequency decreases, speed of light decreases as a square, but it's locally invariant numerically. In other words, it's physically changed, but it has not mathematically changed in terms of a number I would measure locally. Now back to transformations. We get the celery transformation. Again, a prof in Italy has developed a transformation where he says there's clock slowing and there's length contraction, which is why I've argued for those two. And he gives a simple set of equations for that celery transformation. It's the same as the Lorentz transformation, except there's a time difference equation. If you manipulate the mathematics of that time difference and simplify it, it turns out it's that same clock bias that you get from Einstein's synchronization. So yes, the Lorentz transformation works, but it's because you've changed the clock, and it turns out you've changed the scale. Over here, we're looking at that clock slowing, and it winds up, when you look at everything, the speed of light is physically decreased by gamma squared if you're going one way. If you're going back the other way, for example, the Earth, I call the Earth a child frame of the Sun and the Sun a parent frame of the Earth, because the speed of light is physically different in the two frames, and from what we've just looked at. And of course, there would be a galactic frame that's parent of the Sun, etc. So numerically C is invariant, but physically it's not. Okay, a little more one-way Sagnac effect on the Earth. The measurement is the result of Earth's rotation around the Earth. I claim that that's absolutely false. Wang has done some experiments with conveyor belts and shown that their circular equation right there is really equivalent to the length and can be put in terms of the length. Well, on one-way path, you'd expect it to be half as big. The GPS experts claim, there's this triangle that it follows, and they put it in the same form for a one-way because of Earth's rotation. But again, if you work it out, it turns out it's just VL over C squared, and when you put it in terms of where the satellite and receiver are, it works out to be exactly the same as that VX distance along the equator. And so there's clock biases that have to be accounted for in GPS to remove the Sagnac effect. Everybody asks why there isn't one for orbits. Well, there isn't one for orbits because they're all affected by the same amount. You just adjust your clocks. The clocks have been adjusted and are automatically kept that way from the argument we've already given. A little bit more proof of that is GPS has to include all receiver motion in the effect, rotational, and not whether it's just rotational or not. And that's the ICD document that claims that that's the case. So again, it's not a rotation, it's a fact that the receiver and source are moving. Okay, I then come up with what I call the apparent Lorentz transformation, and I say it's a result of the celery transformation along this axis added with a clock bias or removed from a clock bias. And there is a scale change across this, one way when you're going one way and the other when you're going back the other way. Okay, and that has some implications later on. I say, why call the transformation an alternate Lorentz transformation? Why not call it the Lorentz transformation? And I say that's because the interpretation is dramatically different. Yes, the mathematics is the same, but the physical speed is different. And there is a length contraction, even of the Earth, on the order of a few centimeters. Which incidentally, I came across a paper a long time ago, I haven't checked on it recently, when they tried to compute precise orbits with radar of the planets. They did not get the right values, and they tried it with and without Einstein's theories, and it didn't work either way very well. I claim that they're not taking into account this flattening effect and the speed of light changes as a function of direction here. The length contraction is different in different directions. And incidentally, that'll cause a very tiny change in your VLBI measurement of the milliarc seconds. So there's some fun things that they don't account for that I believe we're beginning to see the residual effects of that. The speed difference, the need to distinguish between parent frame and child frame to know whether the scale is changing up or down. It clarifies the need for a specific bias mechanism to account for the clock bias. Special relativity in general seems to think, and as evidenced by the infinitesimal Lorentz transformation claims, that the clocks will automatically be biased under acceleration to still measure the speed of light at c. And that's clearly not the case. They have to be in a gravitational field that's adjusting the clocks properly, or that will not happen. And as just seen by the great satellites, they are not synchronized to measure the speed of light at c because they have not been biased by that proper amount. Okay, so I say it clarifies the need for Einstein resynchronization if the acceleration is linear and not in a gravitational field. Okay, what's next? This is from Sheldon Harris's same Einstein Simplified book. He says, as I mentioned next week in my talk on reversible time. So I'm going to look a little bit here at what's next. Next week or later, to be explained. The anomalous Earth gravity assist, it's my hypothesis that same flattening of the Earth gravitational potential upon a solar orbit. It works fine for any orbit around the Earth because they have the same phenomena effects. But once I use the Earth to send somebody else, I believe, and in fact, the largest Earth gravity assist observed came in directly orthogonal to what that flattening would be. So I think, I haven't worked out the details, but I believe that that will explain the extra acceleration seen on Earth gravity assists. The apparent relativity of gravitational and electromagnetic forces. My last paper that I still haven't had published, I show how a gravitomagnetic effect looks like a gravity effect in a moving system. I intend to try to do the same thing electromagnetically, and I have that outlined, and I believe it'll work. It's a little more complicated than the gravity one. Another interesting thing is that there's a speed kick of millisecond pulsars whenever they collapse down more. And I believe that's just a conservation of momentum effect and the direction of that momentum. They speed up, and therefore I believe it gives them a kinetic kick along axis. Incidentally, in that gravity one, I found that if I have a spinning orbit and I speed it up, I also get part of that spin energy goes into kinetic energy. So again, it indicates it's just like that hidden kinetic energy elsewhere. Spin energy can create hidden kinetic energy when you start moving it. I haven't really done any work on this last point in 20 years, but 20 years ago I did do some work on the relationship between gravitational and electric forces. Now this is hypothetical, and you may have big objections to it, but nevertheless, my conjecture is that there is a relationship between gravitational and kinetic. Gravitational potential, I believe, arises from compression of the ether, and that's why it exponentially decays as distance from the planet. Gravitational forces arise from compressive ether gradient. Gravitational force is locally generated by the local gradient, no travel time. Kinetic force is due to the shear gradient induced by the motion in the ether. Electric and magnetic, I believe, are simply oscillations of the other two. Not, a lot of people think, and properly so, because there's 40 orders of magnitude difference between it, think that gravity is residual electric. I believe it's just the opposite. And when you look at how concentrated the mass is in an atom, for example, I think this might help explain the effect. But electric potential arises from an oscillation in the ether density, I believe. And the electric force is due to the interaction gradient and direction of flow of that ether oscillation. I believe that an electron, for example, by rotating a phase structure, makes it look like that's coming in the inward phase motion because of the rotation. When a positron would rotate in the opposite direction, and it would look like it would be going out. magnetic force is due to the oscillation of the shear induced by the motion, I believe. What is a little bit of supporting evidence for that? Well, for example, in gravity, there's no travel time. In the electromagnetic, to the best of my knowledge, and from what I've seen, it travels at the speed of light. And it looks like that next paper I'm working on, that explains one of the differences between the electric and magnetic as well. There's only one sign to the charge, no repulsion, but if I have an oscillation, I can get plus and minus, inward and outward phase motion. Apparent morphing of gravitational and kinetic into a gravity only. Same way, apparent motion of electromagnetic forces with motion into electric only. Earthquakes induce electromagnetic phenomena. The one in Japan recently, they saw the ionosphere bump up right above it. So I believe that motion of mass, oscillation of mass in particular, can create an electric field, a strong electric field. EO was mentioned in the talk before mine. I looked at it again, well, 20 years ago, and the decameter radiation occurred as EO was in front and behind, and it had opposite patterns. So I believe that's when you'd get the most oscillation of apparent gravity, because one's following the other in either case, and I believe it's what creates that strong electric field. And of course, spiral galaxies. You saw that electric radiation between the stars. Well, those stars are following one another and create an oscillation. So I believe that that it's the gravity or the mass oscillation which causes these huge electric forces. This is a big quote. I'll skip it. We're probably low on time, and I'd like for a little bit of time to ask questions. But one of the famous professors that looked at biochemical processes said at the tail end of explaining it to people, there's no possibility whatever that this system could have arisen by chance. I tend to think the same thing of physics. There's some remarkable mathematics and remarkable design as evidence. So I say be a king like Solomon, search out a matter.